So we've talked about a lot about the components of soil, but we haven't really got into soil taxonomy. And just as with plants, there's taxonomy and classification. So a soil profile is a vertical cross-section of layers of soil found in a given area, and these are broken down into different horizons, and we will talk about each one of these individually. So a soil horizon are layers in a soil profile that are used to classify these soil types. These are based on color, texture, root structure, rock fragments, and anything else that's worth noting. And the master soil horizons are depicted by a capital letter in the order from top to bottom: O, A, E, B, C, and R. So the O horizon is surface layer at depths of 0 to 2 feet, unlikely to have 2 feet in this particular area. It's dark in color, very soft in texture. It's composed of humus and leaf litter that's not decomposed. And some soils actually have several O layers in them, especially more organic soils. Okay, so A horizon is the topsoil horizon. This is the topmost layer of mineral soil. It can be 2 to 10 feet. Again, in our area, our soil is pretty young, so we're not going to have a really well-defined A horizon. Some humus is present. It's darker in color than layers below, and this is also called the biomantle, which this is where you're going to find your organisms like fungi, bacteria, and earthworms. This is the smallest and finest of the soil particles that are found here. Okay, the B horizon is the subsoil horizon. It can be 10 to 30 feet deep, and it's very rich in clay and minerals, such as iron and aluminum. You may get some organic material that reaches here through leaching. Some plant roots may be down there. And if you've got red and brown color, that's due to oxides of iron and clay, and that would be a well-oxygenated soil, not very common in our particular area. Okay, the E horizon is called the leaching layer, and that's the small layer between A and B. It's 10 to 15 feet deep, very light in color. It's going to be mostly sand and silt. Doesn't have a lot of mineral and clay content because it's leached. And this is also where water-retaining plant nutrients are leached into the water table. Soil particles that are here are larger than in the A horizon, but smaller than in the B horizon. Okay, so the C horizon is the regolith horizon, or rock horizon, 30 to 48 feet deep. Large rocks or lumps of partially broken bedrock. It's the least affected by weathering, and you're not going to find any organic matter in this area. And then finally we have the R horizon, which is 48 feet and deeper, and it's continuous rock, and that just depends on what your parent material is as far as what type of rock you might find here. Okay, so podology is the study of soil classification, and a podologist is a specialist in soil classification. So soil classification is based on the physical, chemical, and mineralogical as well as biological properties of soil, and some of the traits may also contain moisture, temperature, color, texture, structure, organic matter, pH, soil depth, etc. So soils are named, mapped as a geologic entity or individual, and the NRCS, which is the Natural Resource Conservation Service, began use of the system in 1965, and there are 12 orders that separate all soils, and some areas may actually have all 12 soil types. Believe it or not, Hawaii has all 12 soil orders. So pedons are identified to help separate soil orders, and this would be a minimum of 3.3 square feet and as deep as the roots are growing. So a pedon is the smallest volume called a soil. Polypedon is a soil body, 2 or more pedons in which the soils are relatively uniform, and then a soil series is going to be a group of like polypedons. Okay, so this is soil formation. You've got your climate, organisms, relief, parent material, and time. Then there are processes that happen, and then the soil properties help with the classification. And while there are a lot of different tiers to this, we are primarily looking at order and family. So in order are major soil forming processes. This is diagnostic horizons. Family are properties important for soil use, such as texture, mineralogy, and temperature. And series is the other one that we're looking at, and that's kind and arrangement of horizons, specific chemical mineralogical properties of horizons. We'll talk a little more about that in a minute. Okay, so when you're doing your using that soil web app, you'll see these orders that are listed depending on where you are. And primarily what we've got around here are the alpha soils, which is the deciduous forest soils, and the andisols, which are formed by volcanic material. And some of these other are in other areas, and I'll talk about each one individually. Okay, here are the dominant soil orders, and here we've got pink, which is andisols, very fertile, but we'll talk about that in a minute. Okay, so entisols have minimal development, and you can see from this map where you're primarily going to find these areas. Very little in our area, quite a bit in the mountain west and the southwest. Inceptisols are immature soils, and we do have some of that. You can see in this map here. And these are just broken down further into other suborders, but you can see we have some around the Puget Sound area because we are fairly new up here. Not very well developed. You can see in the horizon here, it's not a very, the soil horizons. You can't see a lot of definition between layers. Artisols, this is where climate is a dominant factor in soil development, and this is in very arid areas. And you can see there really isn't a lot of definition there. We don't have a lot of organic matter, etc. Okay, gelisols are soils that have permafrost within 100 centimeters of the soil surface, and of course you find this in Alaska, and not well defined and very gray in color, so we're not going to have a lot of oxygen in that soil. Oxisols are highly weathered soils in tropic climates. You can see Hawaii, Puerto Rico, and they're very high in iron and aluminum oxides, very acidic. Andisols, volcanic parent materials, so we have quite a bit of that in our area. Again, not super defined in our layers here, but these are very productive soils and very high in natural fertility. Histosols are organic peat lands or boggy soils, and you can see that's going to be over in the Midwest, in the upper Midwest, and some into Florida. Vertisols are warm, subhumid, or semi-arid climates, and that's going to be mostly in the southwest. Very dark in color. Mollisols, vegetation is a grassland. So this is very fertile, and probably some of the most fertile soil in the world. Very thick, dark colored A horizon, rich in organic matter. You can see that here. Alphasols, these are also climate and vegetation combination dominations. This is in forest or savanna vegetations, clay in the subsoil, and generally very fertile. And so that's going to be again near the Mississippi Valley. Utisols, these are weathered soils in highly humid areas, and this is going to be primarily in the southeast, kind of coming up the mid-Atlantic coast. Very low in natural fertility and high in soil acidity. You need to use fertilizer and lime inputs for this to be a productive soil. You can see there's not much in the way of an O layer or a horizon. Spodosols are coniferous forest vegetation. These are our soils in our forest areas. Wet, cool climate, very acidic, and low in natural fertility. So we've talked about orders, and then there's family. And family are the soil properties important for the growth of plants. This is also the behavior of soils when used for engineering. And next week, we're going to actually take a look at some soils and see if they're useful for what we want them to be for. This will be in our soil survey books. So important soil properties include texture, mineralogy, pH, soil temperature, moisture, etc. And then series, which you've probably come across in your studies of your area. 18,000 soil series are identified. They're typically named after something local. They're different in the basis of observable and mappable soil characteristics. They must have similar color, texture, structure, consistency, pH, chemical and mineralogy properties. So the soil series is the most specific unit in soil taxonomy. It's a subdivision of the family. It has a specific range of soil properties such as kind, thickness, and arrangement of horizons. And actually, I'm contradicting myself. There are about 19,000 series in today's soil taxonomy. And in our area, you'll see Alderwood, Talkle, Seattle, etc. I will be posting in the module. You will see a lot more information on all of these things. This is just kind of an overview.